guys, how you all doing? I hope you all doing good. So in the class we discussed about the UML, that is Unified Modeling Language, right? So we discussed the introduction of UML, what is it, why we need it, and what are the goals of UML. So next comes building blocks. So these three are the building blocks of UML: things, relationships, diagrams. So first is things. Things are the most important building blocks of UML. Here, things can be a structural, behavioral, grouping, and annotational. First one is structural things. Structural things defines the static part of the UML model, and it also represents the physical and conceptual elements. Here, the physical elements are which are real, and the conceptual elements are clear and actual elements. So next are the following brief descriptions of structural things. So first one is class. Guys, you all know what is class, right? What is class? Class is a blueprint or template for creating an object. So here class represents a set of objects having similar responsibilities. So this is the class name, attributes followed by the operations. Here attribute is also called as properties and variables, and operations, methods, and functions. So next comes the interface. Interface is a set of operations which specifies the responsibility of a class. So this interface provides some services by the class, and this is the interface name. So you all know the responsibilities of class. So those responsibilities are specified and defined by this type of interface. So next comes collaboration. What is collaboration? Cooperation, that is partnership between two or more elements. This is the symbol for collaboration, and this defines an interaction between elements. This, what is interaction? Interaction means interconnection between the elements. So next is fourth, use case. So this use case represents a set of actions performed by a system for a specific goal. Here this is a symbol for use case, but these actions are performed by the user, that is we call it as actor, by the system for a specific goal. So next is component. What is component? In general, component means a module or a model. So individual module. This describes the physical part of a system in a UML model. So next comes node. This node is defined as a physical element that exists at runtime. This is the physical element that exists where during a runtime, that is executable time. This contains a web browser, a type of web server, which type of network, etc. So first thing was structural things, and second is behavioral things. This acts between software and non-software system. So this behavioral things contains two dynamic parts, that is interaction and state machine. Interaction, first is interaction. What is interaction? Interaction means interchanging the messages which are exchanged among the elements to accomplish a specific task. What are all the messages exchanged, that is interchanged among the elements to accomplish means to carry out or to execute a specific task from one place to another place. So this is the symbol, that is a sleeping line followed with the filled triangle, that is messages. This contains what? Interchanged elements among the elements. And next is state machine. So state machine or state chart. This is the symbol of state. This tells the state of an object, whether the object is in response state or change state. And next is grouping things. This is the only mechanism to group the elements of the UML model, and this grouping things contains only one grouping thing, that is package. This package contains or gathers all the available elements of structural and behavioral things. So this is the notation of package name. It contains all the gathered information. And next is annotational things. So this, what is annotational? Notation, somewhat comment. So this is the mechanism to capture the remarks, descriptions, or the comments of the UML model elements, and this annotational thing contains one thing, that is note. This note is used to render comments, constraints, remarks, descriptions, all the thing of an UML element, and this is the notation or symbol of the note. It contains it contains a comment, a notation. That's it. And next is relationship. What is relationship? Association. That is, it is the another most important building block of UML. It shows how the elements are associated with each other. This relationship shows how the elements are related between each other, and it not only shows the relation between each other, but it also describes the functionality of the application or the software. And this type of relationship building block, it contains four kinds, that is dependency, association, generalization, and realization. First is dependency. What is dependency? Dependent. One element is dependent on another element. If at all a change in one element occurs, that affects the other element, and this is the symbol, that is notation, dotted line followed with the arrow mark, and dependency. Next is association. So this is the basically giving a link between the elements, means connecting, giving a link, that is connecting the elements in the UML model. It also describes the objects, how many objects are taking part in that particular relationship. So this is the symbol. And next is generalization. In the world of objects, we call generalization as inheritance. What is inheritance? A properties of superclass to subclass inheriting the properties of superclass to subclass. So here which connects a specialized element with the generalized element, that is specialized element is from superclass with the generalized element which is going to the subclass. So symbol is generalization, sleeping line with the followed by a triangle. And next is realization. What is realization? Realizing, that is understanding or consciousness. Here we are realizing that that the elements are connected or not. The elements are connected or not. One here, the which are all the elements connected, those elements describes some responsibilities which is not implemented, and other element describes the responsibilities which is implemented. And this type of situation, that is realization situation, exists in the case of interfaces, and this is the symbol, dotted line with a followed by a triangle. So third building block is UML diagram. So this is the actual place where we get an ultimate output, what we have discussed earlier. So what are all the elements, relationships, elements under discussions where we get an ultimate output. So this is divided into structural and behavioral diagrams. First is structural and second one is behavioral. So these are all the diagrams comes under structural, and these are the diagrams comes under behavioral. So here I will only explain in brief. So these are the 9 diagrams we follow in the lab. So out of these diagrams, we only follow this 9 diagrams in the lab. So these 9 diagrams are explained by upcoming videos in detail. Now I will explain this in a brief. So under structural, first diagram is class diagram. What is class diagram? Class diagram is a static diagram. It represents the static view of an application, and here the class diagram is not only used for visualizing, describing and documenting purpose, but it also used for constructing the executable code of the software. Here we are not constructing the code in your lab, but only we drag and drop the elements or models in the lab and the software. So here this class diagram describes the attributes and operations of a class. Here the class diagrams are widely used in the modeling of a object oriented systems, because they are the only UML diagrams which can be mapped directly with object oriented languages. So second is composite structure. These diagrams are used to represent the internal structure of a class and its interaction with other parts of the system. This composite structure is used to represent the structure of the class and also interacting between the parts of the system. Third is object diagram. These object diagrams are derived from the class diagrams. So the object diagrams are dependent upon the class diagrams. Object diagrams here represents an instance of a class. So here the basic concepts are similar for the class diagrams and object diagrams. And this object diagram also represents the static view of a system. But this static view in this object diagram is a simple snapshot of the system at a particular moment, and these object diagrams are used to render a set of objects and their relationships as an instance. And fourth is component diagram. Here component diagram are used to represent how the physical components in a system have been organized. Here we use them for modeling and for the implementation purpose. And fifth is deployment diagram. Here deployment diagrams are set of nodes and their relationships. What are all the components or the modules implemented in the component diagram? Those modules or components are deployed here, where in the deployment diagram. Next, last is package diagram. Package diagram are used to depict means draw how the packages and their elements have been organized in a well mannered. So this package diagram helps us to organize the UML diagrams into meaningful groups and make the diagrams easy to understand. So these are all the 6 diagrams comes under the structure. Next is behavioral diagrams. Under behavioral diagrams, first diagram is state machine diagram. Here the state machine diagram is also known as state chart diagram. This is used to model the dynamic behavior of a class in response to the time. And it state chart diagram shows the possible states of the object and the transitions that cause a change in the state. What is transition? And transition means delivering the cause of a change in the state. So next comes the activity diagram. So what is activity diagram? These diagrams are used to document the workflows in a system, means a flow of control in a system. And this activity diagram is a variation of the state diagram, where the states which are in the state diagram here in the activity diagram represents as operations, and the transitions in the state diagram here in the activity diagram represents the activities that happen when the operation is complete. And the general purpose of activity diagram is to focus on flows driven by internal processing versus external events which occurs in the model. And next is use case diagrams. These use case diagrams are used to identify the functionality provided by the system, and these functionality, that is the operations or actions performed by the actors, and these are used to depict means draw the functionality of a system or a part of the system. And next, fourth is sequence diagram. Here the sequence diagram displays the time sequence of objects participating in the interaction. Here interaction means interaction between the objects in a sequential order. Here in this sequence diagram, it consists of 2 dimensions, that is vertical and horizontal dimensions for the different objects. And next comes fifth, that is communication or collaboration. Here for collaboration diagram is also called as communication diagram. Here in the communication diagram, it displays an interaction organized around the object and their links to one another. Here this diagram is used to show the sequential messages which is from the sequential diagram. So those messages are exchanged between the objects in which diagram? Collaboration diagram. So next, sixth is timing diagram. So timing diagram is used to depict the behavior of the objects over a time frame, and we need this time diagram to show the time and duration of the changes which occurs in the objects of state and the behavior between the elements or objects. So next is seventh, that is interaction overview diagram. here it models a sequence of actions and helps us to simplify the complex interactions into simpler occurrences. Here what are all the interactions have been done which are in complex mode. So this diagram helps us to simplify this complex into simplex occurrences, and this interaction overview model is a combination of both activity and sequence diagram. So these are all the diagrams, and these are the 9 diagrams. I will go explain in the next coming video in detail, means individual diagrams, so along with the example. So thank you.